Hello, everyone. Thank you for joining ClicData in our webinar series. Today, we're going to be speaking about common data issues and how to solve them using ClicData. I'm your host, Rob Wood, and our subject matter experts today are Christian Mindu and Dan Stelges. I appreciate everybody joining us today. A couple things before we get started. Please let us know in the chat, which is at the bottom right of the screen, whether or not we have any issues with audio or video. The webinar will be recorded today. That way you can review it later at your leisure or share it with a colleague. If you have any questions during the webinar, feel free to use the chat box in the bottom right-hand corner. Today, our webinar is for ClicData users looking for expert tips to take full advantage of our data management module. ClicData users who would like to understand a few use cases and how to use SQL transact functions. And finally, ClicData users who would like to optimize their ETL process on ClicData. We're going to review some of the most common issues and some solutions for those, including using SUBSTRING and care index to extract specific parts of a string, converting string columns to date, the JSON value parser, using data merge versus aggregation, using macros to optimize the data load, and creating cumulative sums on a view. A little bit about ClicData. We were the world's and are the world's first cloud-based BI platform. We've been around since 2009. Very happy to be helping customers with over 1 million KPIs being currently managed, with 100,000 or more dashboards being published every hour. Over 4.5 out of 5 stars and a 95% recommendation rate, which we're very proud of. BI requires 4 steps to be successful. You need to be able to connect to your data, prepare your data, of course, build that visualization, and then publish and share. Today, we're going to be speaking about how to better prepare your data, get better ETL, and get more power out of what you already have. I'm going to turn it over to Christian now.
Thank you, Rob. Hello, everyone. My name is Christian, and thank you for joining today. And so I'll be covering several topics today regarding data management and how you can use ClicData to sort of transform your data and ensure that it is appropriate for visualization. And so the first topic I'll be covering today is using SUBSTRING to extract parts of a string. And so oftentimes when you upload data, you may notice there are multiple attributes, combined into a single cell value. And so the issue here is that you cannot visualize individual attributes if they are imported in that manner. And so if you don't know or don't understand what I'm saying, I do have an example here where we have ABC-123 as a cell value, where we need to extract the term ABC and create a dedicated column for it. And so how do we do that? And so after your data has been imported, what you can do is create a view to access our data transformer, where you can either use a calculated column or an update transformation. The choice is yours. A calculated column would create a new column retaining the original column that you had. The update transformation would replace the existing column that you had with the new contents, depending on your formula. And so, moving on, as we can see here, we created a view from our data source, and we used the SUBSTRING function to extract the car make of my data. So yes, I am dealing with transactional car sales, in which I have a sales ID column containing the car make, followed by a dash and an auto-generated number associated with that car make sale. And so what I'm looking to do is extract the car make from the sales ID column, so I can create its own dedicated column, which I can then use to interact with on a dashboard, whether I'm looking to filter by car make or categorize my metric columns by the car make. So to do that, we use the SUBSTRING function. And to sort of talk about the SUBSTRING function a bit, it does require 3 parameters. The first parameter being the column that we are looking to parse by. And so as you can see there, it is enclosed within square brackets, which is required. So in my case, what I would have is the open square bracket, sales ID, and then close square bracket. The second parameter is the start location. So from which point do I want to start parsing my values from? And so in my particular example, the car make, which I'm looking to extract, starts at the beginning of the each string. And so this applies to all car makes or all possible values that exist in my data. And so since that's the case, my start location would be 0. And then the third parameter is the number of characters that I'm looking to parse by. And so the problem by just using a fixed number here is that, car makes, contain several characters. It can vary depending on the make itself. So if I were to theoretically just use 4 for BMW, yes, that would work, but for other car makes, it would not parse properly. And so what do we need to do here? And so what we need to do is use a function called character index, which returns the index position of a specified character or string, whichever your requirements depend on. And so to talk about the character index function a bit, similar to the substring, it does require 3 parameters. The first one being the search term or the character. In my case, I want to locate where the dashes are because I will be using that as a reference for my sales ID. So I do use a dash enclosed with apostrophes. The second parameter is the column reference. So similar to the substring function, we pass the sales ID as the second parameter enclosed with square brackets. And the start location, so this indicates where, from what point do I want to start looking for that character or search term. And so in my case, because my character is in the beginning of the string, or my karmic is in the beginning of the string followed by that dash, then I could just use 0 to get that index position of that dash. And so in this case, what would happen is that my character index function would return 4. And as a result, having all these parameters together, I can successfully extract the car make from the ID. And so with that, I have a dedicated column that I could use, as I mentioned earlier. So the next topic I'll be covering is an extension of the previous topic. However, it does involve date columns that have been imported as a string. And so this tends to happen if you are uploading data sources from a local file like an Excel or a CSV file, or even a cloud application such as Dropbox, Google Drive, OneDrive, or even Google Sheets. You may notice that before you import the data, the sales date column is being read as a text or a string, as seen by the A icon beside the column name. Even though my values represent dates, it's not truly formatted to be interpreted as a date column. And so because of that, I would lose the chronological properties of my values. And so when I visualize this on a dashboard directly, I would not be able to visualize my data over time, whether it's grouped by year or year month, so on and so forth. And so to solve this, we do need to create a view similar to the last step, where we could apply a formula, whether it's from a calculated column or an update transformation. Either works, but we do need to supply the correct formula. So in my case, I use the date from parts function to achieve this. And so to talk about the date from parts function, it does require 3 parameters: year, month, and day, in that exact order. However, my date values are actually ordered by month, day, and year, with no dashes or anything in between, and it's just purely numerical. So that within itself is not a true date format. And so what we need to do is, with the date from parts function, we need to combine that with with string functions. So what I use are right, left, and substring to extract these elements. And so the right function in this case will extract a certain number of characters from the right side of my string. And because the year element is at the very end, I want to extract the 4 characters from the right side of that string, which would yield 2017. And then the opposite of that is the left function, which extracts a certain number of characters from the left side of the string. So since my months are first, I do want to take the first two characters from that left side to get my month, which would be 12. And then we do have substring for our day parameter. And because the day element is in the middle of my string, we need to specify where we want to start parsing by and how many characters to parse by. So because the date element starts on the third character of my date value, we set the second parameter as 3, which is the start location. And then the last parameter to how many characters we want to start by, parse by. We enter 2 to take the 2 numbers from that third point onwards. And so just using that first row as an example, that would give me 30. But of course, this loops across all values in my column and constructs a true date column. And the way you can tell is if for one, the formula does execute. So that's one. If you do get an error, then there was some issue with parsing your date value. But on top of that, you can also see the calendar icon, which does represent a date column. And so with this column, I can now have access to the chronological properties of my data. So say if I want to visualize something by month or by year, whatever the requirements may be, revolving dates, the possibilities are there. So moving on, the next topic I'll be discussing is the JSON value parser. And so this is a topic that I have personally come across. Most of our customer base do ask, how do you work with this data? And it is a valid question. And there couldn't be a better time and place to sort of talk about JSON objects and how to work with them. And so for those who don't know what a JSON object is, if these values tend to arise when importing data from an API via web service. And as you can see, a JSON object is in a single cell value, and it is enclosed, or you will notice there are multiple attributes enclosed within squiggly brackets, as you can see here in my example. In my example, I have model of the car, whether it was a convertible or not, the type of the car, and the country. And the problem with this is that because there are multiple attributes enclosed in a single cell value, I cannot interact with each individual attribute on a dashboard. And so what we need to do is extract these elements individually into their own dedicated columns. And of course, you'd use a view to achieve this. And for JSON objects, I would recommend the calculated column, just so that you can retain the original JSON object as well as have dedicated columns for each attribute. So instead of using string functions to locate these elements, what you can do is use what we have available is the JSON_value function, which is a transact SQL function, of course, which is used to locate particular elements, whichever of your choosing, and extract them to its own column. And so to talk about this function a bit, it does require 2 parameters. The first one, of course, is the column you're looking to parse. And then the second column, or second parameter rather, is the path to that attribute. And so just keep in mind that the example I'm using for this webinar is very simplified, just for explanation purposes. So you may expect JSON objects that are much more sophisticated, much more multi-layered. And in those cases, I do recommend checking out Transact SQL's documentation for the JSON value function. They do have detailed examples as to how to navigate through syntactically on how to drill down on multiple layers of objects. But in my example, for that parameter, what we need to do is create open apostrophe and followed by the $, which represents the root node or root level of that JSON object, and then followed by a period, and then the attribute name. And so in my case example, I am looking to extract the country of my JSON object. And so all I need to do is just put country and then close that apostrophe and then close that circle bracket to complete the JSON value. And as you can see in my screenshot, I do successfully extract the country. And so now I do have access to categorizing or visualizing my data by this new column. So the last topic I'll be covering today is the data merge versus the aggregation transformation. And so we are aware that there are overlaps between the two, and both can be applicable for certain requirements. But just to talk a bit about the two, a data merge is used to join two or more data sources, where the user can just choose and select particular columns to be in the finalized merge, in which these tables or these data sources would be merged based off of a primary key or a super key. In other words, a common column or common multiple columns between the two tables or more. But something to note when using a data merge is that if your data sources contain a many-to-many relationship, the merge may result, or most likely will result, to duplicated rows. And so I know this is a topic that has been raised to us from our customer base. But if you were to go ahead and visualize this result on a dashboard, your counts may be double counted or triple counted, but nonetheless, they are not correct. And so that is a primary example of when not to use a data merge. And so to talk about the aggregation transformation, it is used to aggregate a single column from another data source that is, again, logically joined based off of a column or multiple columns. So it does, the logic behind the two are very similar. However, one thing that the aggregation transformation has over the data merge is that it is much easier to perform mathematical aggregation. So sums, averages, minimums, and maximums, and etc. And so which one should you use? Yes, they do have overlaps, but for this webinar, we will outline specific examples where each one should be exclusively applied. So starting with the merge, my example here is I have 4 tables. The top left table contains the car sales, so each transaction. As you can see here, I do have car ID, a location ID, a sales day of when that car was sold, and the employee ID. However, because they're IDs, I don't know, there is a lot of missing information which are contained in other tables. So using the car IDs, for example, on the table on the top right, I do have a car ID table indicating that car ID A is under Mazda's Mazda brand. And then say, for example, the location 1, is in Canada, which is in the North American region. And same for employees. I have that information just spread out across multiple tables. But what I'm looking to do is have those fields or columns in a single data object that I can then use on a dashboard directly. So here is an example of a merge that would achieve that requirement. So as you can see here, I do drag each individual table to my merge editor, where I then link the common columns between each data source. So as you can see in the car sales table is pretty much the nucleus of this merge, where I link the car ID together and the location IDs and the employee IDs. But as you can see on the left side of each column name, what I do is I deselect the ID columns, and simply because I'm not interested in interacting with those columns on the dashboard. So my merge as an end result will not include those columns, and it will only include the columns that are checked. And at the top of that merge editor, you can see the end result and what it would look like. And as you can see, I do have the sales IDs, when the car was sold, the price, the make, where it was sold, and who it was sold by. So I can use these attributes on my dashboard directly now that I have merged them together. So an example of where to use the aggregation transformation, let's say I have 2 data sources. One, it represents car sales for 2017, and another data source represents car sales for 2016. They do have a similar structure in this case. And so this aggregation example, what it's doing is that it's creating a new column for total sales of the previous year. So just keep in mind that I did create a view from the 2017 data and use an aggregation transformation in that view. And in the aggregation settings, I do reference the 2016 data and select that total price column for aggregating. And then I use the sum as the type of aggregation. And then at the bottom, I do logically join the two tables together. This is similar to how the merge works, but through drop down boxes. And as you can see, at the very first join, I do join it by year. However, something to note is that I am subtracting 1 year from the join. And so if I were not to do this, this aggregation would look to my 2016 data and look for data that falls under 2017, which doesn't exist. So if I didn't subtract 1 from it, it would not yield any result. So that's one crucial thing to note when using the aggregation transformation. And then month and day, those elements are consistent, so I could leave those as is. And as a result, you will see a new column. I called it total sales last year. And what this indicates is that for that corresponding month and day, so maybe taking the first row, for example, I have December 30th. This new total sales column is displaying that total sales for that exact month and day, but for the previous year. And so now I have 2 columns. I would have total sales for the current year and total sales for last year. And you may ask, what is the significance of this? And so a common requirement that I come across quite often is, how do I calculate a year-over-year metric? And so this structure, having 2 columns, current year and the previous year, that is the ideal structure to calculate a year-over-year metrics more efficiently. Theoretically, what you could do is create a chart, or table, whatever visualization you're okay with, and then plug in both of those columns as values, and then create a calculated column within that chart or table, where you can then divide the 2 columns together to calculate that percentage change. Okay, that concludes my part for today's topics. I will now pass it to Dan, who will cover our remaining topics.
Thank you, Christian. Good morning, everyone. I'll be talking about 2 additional topics in regards to data management. The first one we'll talk about is using macros to optimize your data loads. Where we use this is when we're dealing with database refreshes of your data sets. There may be instances within the databases that you're working with where you don't want to retrieve all the data that's in the database for a particular table or a set of tables. You may want to segment that data by various clients or accounts, or even by various time periods. And that may be variable depending upon the requirements that you may have. Using the macros within the database query option and using the formula editor, we can apply within the where query of your SQL statement limiting criteria to bring back only the data that you need. The syntax for using the formula editor is evaluated and sent to the SQL database. You just need to remember that when you're using this option to enclose your formula within curly brackets, we do have some built-in macro functions available that you can use. However, you can also create your own functionality depending on your business need. Maybe if it doesn't fit squarely into the pre-built macros that we have out there. So just as an example, we have a database query where we have a requirement to only retrieve data for accounts that are actually active. We don't have a way within the database system that we're working with to know whether those accounts are active or not. In this scenario, because we have multiple accounts and we don't know whether they're active, we've created a custom table within ClicData to track those accounts and to indicate whether those accounts are active or not. This would allow us to dynamically, when we run our refresh queries to reload or append data, to only select the data for those accounts which are active. In this specific example, we are creating a query that selects using the other function, the other macro, that selects from the list of accounts in our custom table, selecting the enterprise IDs that are active. When we do that, we end up with a query string value that'll show in your editor, where we're saying select all from the table where the enterprise ID is in the list of accounts. So we're using the standard functions within ClicData to retrieve that information from the table using the data to list. That results in us getting a query that's equivalent to what you see here, which is select all from the table where the enterprise ID is in 1, 2, 3, if you're looking at it in SQL terms. The next data scenario we'll talk about is creating cumulative sums on a view. In some instances, we may want to do this operation within our dashboards. We know that we can do some cumulative sums within some of the widgets. However, there may be advantages to doing this within the view ahead of time. Some advantages are centralizing that KPI within your system to one view, especially if you're going to reuse that KPI across multiple dashboards. You may also be able to simplify some of your dashboard calculations with using this view and having the KPI pre-calculated. It also gives you an option too, in using functionality we talked about earlier with the data aggregate, that we could look up progress to budget or goal, which is a typical scenario that we see. So knowing where you are within a certain period of time and how you're getting to and how you're progressing to that budget or goal based upon where you are at within here. How would we go about using that? Obviously, we're going to add a calculated column to our view, and we can use the SQL over partition by functionality to calculate a rolling sum over a window of time. For our example here, we would want to calculate the overtime hours by our enterprise entity and fiscal year. So we want to see within the fiscal year, depending on the period we are in the fiscal year, how many overtime hours have we accumulated. As you can see with the resulting data, what will happen is we'll calculate for fiscal year 2019. At the very bottom, we have a calculated rolling sum. When we flip over to 2020, we begin to recalculate that rolling sum all the way up to the end of 2020, and then start over again on 2021. Once you have that calculated, then you can use that within your dashboards based upon your KPI scenario. As an example, we're showing a dashboard where we're showing for 2020, how do we compare to the previous years for overtime and that trend over those periods within the fiscal year. That concludes my portion of the presentation. I'll turn it over to Rob for any questions.
Thanks, Dan. Thanks, Christian. I appreciate that. Definitely informative, and it's always good to hear you guys. So we do have a couple questions, and I believe this one's for Christian. What is the best way to structure a pivoted data on ClicData?
Thanks for the question, Rob. The best way, if your data is pre-pivoted, you could use the unpivot transformation in the view. So that is its own transformation. Unfortunately, we didn't have any examples of that in today's webinar, though we highly encourage you check out our documentation to learn more about it.
Perfect. I think this one's for Dan. Dan, can you use macros along with stored procedures while executing a SQL query?
Yes, you can. And actually, we made a simplified example here just for illustrative purposes. But you can get a little bit more complex if you have the ability to create stored procedures on your store system to pass different variables or parameters and be able to parse that within your store procedure to make it more complex.
Awesome. And then I think our last question is, can your system also do a union where I can combine 2 or more files together as stacks?
Right. Yes, you can. And we call that the data fusion. And so like maybe just an example here, if I had like that 2017 and 2016 data, as per my example, you can use the data fusion to actually stack them together into one object and then use that on a dashboard if you'd like.
Awesome. Thank you. Well, that's it for our questions. I want to thank everybody for joining us. If we were not able to get to your questions or you have an additional question that you would like asked, feel free to email our team at support@clicdata.com. You can also reach out to sales@clicdata.com. Also, you might find our YouTube channel very helpful, plenty of tutorials there. And everybody here that is registered and attended will receive an email that includes a link to the recording, as well as the various ways to get in touch with our support staff and business staff. Once again, I want to thank everybody for your time. Christian, Dan, great job. Everybody, thank you, and have a wonderful rest of your day.